engineers have developed a turbine which has the potential to power a small town, all the while being no bigger than your office desk. Designed by GE Global Research, the turbine could power 10,000 homes and, according to researchers, could help to solve some of the world's growing energy challenges. But rather than steam, which is typically used to set turbines in motion, the new turbine uses carbon dioxide. This compact machine will allow us to do amazing things, said Doug Hofer, lead engineer on the project, in Albany, New York. The world is seeking cleaner and more efficient ways to generate power. The concepts we are exploring with this machine are helping us address both. According to MIT Tech Review, the turbine is driven by supercritical carbon dioxide, which is kept under high pressure at temperatures of 700 C. Under these conditions, the carbon dioxide enters a physical state between a gas and a liquid, enabling the turbine to harness its energy for super-efficient power generation, with the turbines transferring 50% of the heat into electricity. It could help energy firms take waste gas and repurpose it for efficient and cleaner energy production. Waste heat produced from other power generation methods, such as solar or nuclear, could be used to melt salts, with the molten salts used to the carbon dioxide gas to a supercritical liquid, which may be much quicker than heating water for steam. GE confirmed the power cycle is a closed loop which circulates the CO2 continuously around the cycle, and that there are no waste products from the system when used with solar energy. The team is reportedly working with U.S. government agencies to test the turbines, working on projects with the Advanced Research Projects Agency Energy and the U.S. Department of Energy. Furthermore, the turbine's design would enable it to be powered up and shut down easily, could make it useful for grid storage, an issue with renewable sources such as wind and solar. Currently, the design of the turbine would enable up to 10,000 kilowatts of energy to be produced, but the turbines could be scaled up to generate 500 megawatts, enough to power a city. The technology is still in its early phase, but researchers hope to put the turbine through its paces later this year. Industrial-scale testing will also make commercial pricing clearer. With energy demand expected to rise by 50% over the next 2 decades, we can't afford to wait for new, cleaner energy solutions to power the planet, explained Hofer. We have to innovate now and make energy generation as efficient as possible. Programs like those we are working on with the U.S. Department of Energy are helping us get there. A 3D printed model of the turbine has been made to demonstrate the principle, but a final version of the current prototype would be expected to weigh just 150 pounds, 68 kilograms. The approach of repurposing heat to generate molten salts is the basis of certain types of solar power generation. Concentrated solar power is a technology which uses mirrors and lenses to reflect sunlight onto a narrow area. The resulting heat melts the salt, with the molten salt they use to boil water to steam, driving a turbine. Unlike photovoltaic technologies, used in the typical solar cells of panels seen on houses, CPV can work for hours after the sun goes down.